Alright, so now we're going to talk about circles. So before we get started, we're going to go look closely at our circle and identify everything that we can. So if you notice, from B to O, that's a radius. And even though from A all the way to C is a diameter, we can also classify O to C as a radius and O to A as a radius. So here, purple is going to represent radius. So let's change the color. And A to C is going to represent my diameter. Now, here we also have two chords. We have chord AD, and we also have chord DC. So, chord will represent by blue. Now, here we also have DC can also represent two things. Again, one, it represents a chord, but at the same time, it can also represent your secant line. Secant line, remember, goes through the circle, whereas a chord, its endpoints are on the circle. So you can think of a chord kind of like stopping at the edges of the circle, where a secant goes straight through the circle. Which brings us to the next thing, which is what we call a tangent line or a tangent. Tangent, they're important because remember, they are going to be perpendicular to the circle, or in other words, it only touches the circle once. Tangent. Alright, so now let's go through and answer the questions that they want us to answer. So looking at number one, it says AC. So A to C is going to be the diameter. So that's B. We use that. And it says line CD. Line CD, we said, represents a secant line. So F. And that's that. Number three, it says segment AD. Segment AD, we said, represents a chord. So E. And the next one is for number four, it says angle AOB. Angle AOB is outlined right here, which represents your central angle. So D. And angle CAD. Angle CAD is going to be this angle there, and that is what we call your inscribed angle, or C. And then it says arc ADC. Now normally whenever you see three letters, it represents a major arc. Nonetheless, ADC, in this case, they're telling you the direction of your semicircle. And we know it's a semicircle because it starts at A and it ends at C, and A to C represents your diameter, so it's outlining half of the circle, and that's what we call it, a semicircle, or J. Ray AE, notice how we already labeled it as our tan or tangent, so that's G. And then arc BC. BC is going to go from here to here, which is less than 180, so that's what we're going to call it, your minor arc, or H. And then segment OA, we also said that's your radius, so A. And last but not least, arc BDC. B, we notice I'm going to use yellow. It starts at here, at B, goes towards D, and stops at C, which is more than 180, and so that's what we call your major arc, or I. Moving on. It says if the radius of a circle, so if R is 5, what is the circumference? Well, remember, circumference can be given as two ways. The first one is as 2 pi times the radius, or it's also diameter times pi. Now in this case, we have the radius, so we're going to substitute it in there. So circumference is equal to 2 times pi times the radius, or circumference is equal to 10 pi, which is approximately 31.42. Moving on. So they're telling you that the circumference, so C, is equal to 80 pi. And they want to know what the diameter. So here we can refer back to the two equations that we put, which are up here. And notice how one of them has diameter in it, the other one has the radius in it. Now because they're asking for the diameter, it would be wiser or wise to use circumference is equal to diameter times pi. If we compare this equation to the circumference that they gave us, if you notice, the pi's are both there, which means that the diameter is actually 80 centimeters. So not much math involved in that one. 13. It says the radius of a circle. Okay, so radius is 14. And the measure of the arc, ABC, is 250 degrees. And they want us to find the length of arc ABC. So they're asking for arc length. Remember, arc length we use the formula x, which x represents your central angle, times 3 over 360 times circumference, which is 2 pi r. And so in my calculator, if I use parentheses to find my arc length, I'm going to put in parentheses x, which represents your central angle, or 250 over 360, parentheses, and then parentheses again, and I have 2 times pi times 14. So I put all of that in the calculator, and I get an arc length of 61.09. 14, it says the diameter of the moon is 2,548 kilometers, and an orbiting lunar station is circling around the moon 32 kilometers above the lunar surface. Find the distance traveled by the lunar station in one orbit. In other words, find the circumference of the orbit. Find the circumference of the lunar station. And so we're going to draw our diagram here. So the first thing we got to figure out is if this represents the moon, then this diameter is 2,548 kilometers. And it says that the orbit, that the lunar station is orbiting 32 kilometers above the moon. So if it's 32 kilometers around the moon, all the way around, even over here, is also going to be 32. And so really the path of the lunar station is always going to be 32 units more. And so really we have to find our new our new diameter. And so this new diameter is going to be whatever 2,548 is plus 62, or the 32 that were added on both sides. And so really, my new circle has a diameter of 2,612 And so if that's my new diameter, Then to find the circumference, remember we can do diameter times pi. So my new circumference, or the distance that's going to be traveled around one orbit, is whatever 2,612 times pi is in kilometers. Or if we actually put in the calculator including pi, we get an answer of 8,205.84 kilometers.